All right, so last page we did was just talking about what constant of proportionality is. So it's the idea that it's the unit rate when something is proportional. Today, we're going to go and apply this to a couple different representations. So on here, you can go ahead and left click on it, then right click, save to keep. Then we'll go ahead and open in the new tab. I'll click it again so I get the pen. And here we go. So along the side, put a couple of reminders for you. One of them is that the constant of proportionality, we said also called K, is the unit rate. And when we have an equation, it's always going to be the y equals kx. Y and x could be other variables that fit the problem, but that's going to be your basic idea. So first problem, we have bananas are 59 cents per pound. So in other words, 1 pound costs 59 cents. So the first question says, what is the constant of proportionality? Well, the constant of proportionality is the unit rate. So if it's 59 cents for 1 pound, then my constant of proportionality would be 0.59. So just that number there that represents the unit rate. And I don't have to label it for our purposes here, so we don't have to put the cent sign, just leave it 0.59. So the next one says, what's the equation that models the relationship between the total price for bananas? So we have two variables in the problem. We have the cost, the price that I'm going to pay for bananas, and we have how much they cost per pound, okay? So if I call y is going to be my total, oops, let's make that y a little better, and x then is going to be my number of pounds. So those are the two things we don't know. We don't know how much total we're going to spend, and we don't know how many pounds we're going to buy. Oops. DS, sorry. So when we go ahead and write our equation then, the total amount of money you're going to spend at the store is going to be your y equals, then I do k times x, right? So my constant of proportionality times the x. So it costs 59 cents for 1 pound, so it'd be 59 times 2 for 2 pounds, or 59 times 3 for 3 pounds, or 59 times 4, 4 pounds, and so on and so forth. And so that's why that works out. Okay. The second question is the same idea. It's a situation that we need to find the constant of proportionality from, but this time it doesn't have a 1. It says there are 3 cans that store 9 tennis balls. So we're going to look at number of balls per can, okay? So first is to find the constant of proportionality. So that's finding the unit rate. So it told us we were supposed to do balls per can. So I'm going to do balls divided by can. So my balls number was 9 and my cans number is 3. So my constant of proportionality would be 3, because 9 divided by 3 is 3. What does it mean in the context of the situation? So if I give it its labels back, it means that there are 3 balls per can. And that's pretty much it. 3 is your constant of proportionality, and then you have balls per can. Okay? So if I write the relationship, we have y, which is going to be my total, which is going to be my number of balls altogether. And my x is going to be my number of cans. So we know if you had 1 can, you'd have 3 balls. If you had 2 cans, you'd have 6 balls. If you had 3 cans, you'd have 9 balls, and so on and so forth. So to represent that relationship as an equation, we say, how do I find how many balls I have altogether? I take the number of cans and multiply by the unit rate, that 3 there. So that's going to be my equation. Last but not least, we got John works in an ice cream store. His wages are shown in the table. So this time we have to pull the information from the table instead of from the situation. But everything we do otherwise is going to be totally the same. So I said find the constant of proportionality, and what does it mean? So the constant of proportionality is going to be my unit rate. So I want to do dollars per hour. So I could pick any of the points on here. Me personally, I like smaller numbers, so I'm going to pick the first one. But you could pick any of them because remember, if it's proportional, they all have the same unit rate. So meaning you could do 36 divided by 4 or 27 divided by 3 or 18 divided by 2. It doesn't matter. So 18 divided by 2 is 9. And if I go back here for my label, we were doing dollars per hour. So it's $9 per hour. So that's going to be John's salary, right? He works in an ice cream store and he gets $9 for every hour he works. So like the table tells us, when he works 2 hours, he gets $18. If he works 3 hours, he gets 27. If he works 4 hours, he gets 36, and so on and so on and so on. So if we write this equation here, we know our kind of total thing, our y there, is going to be his total money that he takes home. And that depends on how many hours he works. So that's going to be your number of hours. So when I figure that out, then I have that it is my total money I make is the number of hours that I work times that unit rate there. So that's going to be my equation. I'll go ahead and go back here. We'll go back to my notebook. I will delete this one out. I can copy this one, make it fill my space, and that's my idea. So you're finding the unit rate, same thing as constant of proportionality. And then when you make an equation, you're putting that unit rate as a part of your equation there. And it's always going to be that y equals kx or, other variables if we use other ones. Okay, nice job.